yeah. All right, peace, guys. Love,
It's
science.
so great to see you all. And of course, we're going to start off Funky Science Story Hour, Earth Day edition, with the Funky Science Story Hour theme song. Gather around, my children, pull up a chair, my friends. Let's all get together for the story that never ends. How did we get here? What's inside your head? What's bluer than blue? What's bluer than blue? What's redder than red? Gather around, my people, all children, young and old. Pull up a seat, put up your feet for the greatest story ever told. Funky Science Story Hour, 'cause knowledge is science and science is power. 'Cause the world is so weird and weirdness is fun. 'Cause there's so much to learn and we've all just begun. Whoa, we can learn together, we can understand the weather, we can imagine ourselves in any place, we can see the earth from outer space. How do we do that? Oh, with science. Funky, funky science. Yeah, science, 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 funky, funky science. Whoa, funky, funky, funky science, yeah. Whoa, Funky Science Story Hour, 'cause science is knowledge and knowledge is power. Because the world is so weird and weirdness is fun. There's so much to learn. Yeah, we can learn together, we can understand the weather, we can imagine ourselves in any place, we can see the earth from outer space. Really? How do we do that? Oh, it's science. Funky, funky science. Yeah, science, science. Funky, funky science. Whoa, science, funky, funky science, yeah. Whoa, it's science. Funky, funky science. Yeah, funky, 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 funky science, yeah. Whoa, science, science, funky science, yeah. All right. Welcome, welcome. Funky Science Story Hour. Happy Earth Day. And I'm so psyched to see there are people with me now. And we're hanging out on this Wednesday afternoon. Well, it's afternoon for some of us, depending on where you are, on this spinning Earth, where it's day side on one side and night side on the other side. And it rolls around as we roll under and away from the sun. So where I am, it's afternoon. I see somebody just joined from San Francisco, where it's about the middle of the day now, getting on late morning. And it's so cool that we're all connected here on this Earth of ours. It's a weird time to be alive in some ways, isn't it? But it's a great time to be alive in other ways, because here we are, connected. Let's all hold electronic hands together and let's talk about some funky science. I got some questions that have been rolling in and some questions that came in since last time that I want to get to. And I have a song that I just learned that seems appropriate for Earth Day that I'll play for you, a song I'll play for you in a little while. But one thing I wanted to do, just because it is Earth Day, did you guys know it was Earth Day? And it's not just any Earth Day, it's the 50th anniversary of the first Earth Day. And so that's pretty cool. Let's just imagine ourselves 50 years in the future on the 100th anniversary of Earth Day in the year 2070. And what will the world look like then? And will we have learned to handle ourselves on this planet a bit better than we are now? I mean, we've learned a lot of really cool stuff with science, right? We've learned some stuff, amazing things about how the Earth works, how our own bodies work, how life works, about outer space. We've learned so much. And yet we have all that knowledge, but what are we going to do with it? We're living on this Earth and we need to take better care of it. And we need to use that knowledge. It's not just enough to be clever and figure out and say, oh, we're so smart. We're these smart human beings. We know so much about the Earth. Well, it's like, okay, if we're so smart human beings, let's do a better job and take care of our Earth. Okay, we know what to do. We just got to do it. You kids out there, you're growing up and you're going to be adults soon. And I believe you're going to do a better job of taking care of this planet because you know so much. And we have to do everything we can to try to help that along. And I've been talking about some of those things in other Funky Science Story Hours. We talked about that carbon dioxide we're putting in the atmosphere. I mean, it's cool that we understand about carbon dioxide and the radiation, the infrared radiation, and how that relates to the amount of these gases in the atmosphere that absorb that light and heat up the planet. I mean, that's really cool. But the next thing is like we have to act on that knowledge and change the way we get energy and just do a little bit better job of taking care of this planet. I think we can do it. Human beings learn. We do learn. We learn slowly sometimes, and we need to pick up the pace here and change. Stop driving, change the kind of cars we're driving or not drive so much, and just change the way we do things and take better care of this beautiful planet we're on. Now, so Earth Day, yeah, 50 years. Every year there's this day in April where we stop and we just think about, celebrate this planet, which is great. I love it. I mean, we've got other holidays, right? We got the 4th of July where we say, oh, our country's so great. And that's, there's a lot to celebrate there. And we've got, we celebrate famous people on other days and we have religious holidays. That's all cool. But like, here's a day for the Earth, our home, our mother, our planet, the place we live, the environment we inhabit and that we're part of and that we've grown out of, we've evolved with, and this planet that we're changing and we're learning about how we're changing it, and we're going to change ourselves now with that knowledge. So let me talk about a couple of my favorite things about the Earth. In fact, I got one question. I don't remember who it was from, but somebody said, oh, let's become cybernetic organisms and live forever. Okay, Bart, that's a great idea. You first, Bart. All right. But somebody there was a discussion of somebody saying, well, what are your favorite things about the Earth? And I'm going to tell you one of my favorite things about the Earth, and that is water. Earth is a water planet, and I love water, don't you? And especially now that we've seen other planets, and we've got pictures of Mars, and we've got measurements of Venus, and all these other planets in the solar system, and even now some other planets outside our solar system, one thing we're realizing is that one thing that's really special about Earth is that it is a water world. If you look at Earth from space, you see that most of the surface is ocean. About 2/3 of the Earth is ocean, not land. But not only that, water is so important for giving Earth all of its best qualities. All the best things about Earth are related to water. For one thing, life. Life is here on Earth in a lot of ways because of water. If you look at what life is, if you look inside any living thing, remember we talked about cells? If you look inside of our cells or the cells of any organism, what you find is water with other chemicals floating around in the water. And it's the way that all those chemicals float around in the water and get together with each other in different patterns and structures that makes life happen. It's really the water that allows the chemistry of life. And so it seems so important to life that now when we look for other planets in the universe and we try to understand where there might be life, one of the main things we look for is water. But it's not just water on Earth, it's also water at a certain temperature. We've talked about the climate of Earth in other Funky Science Story Hours and how the balance where the energy comes in from the sun and some of the energy goes back out into space, and it's just that right balance that makes the climate a certain way on Earth. And it's the fact that Earth's climate, Earth's temperature, is in the right range so that the water on the surface of the Earth is liquid or mostly liquid. That's amazing. I mean, you can see here in this glass that I'm drinking, there's water in the liquid form. That's what we usually call water. And then there's water in the solid form, which we usually call ice. And as I sit here and talk to you, and this water heats up to the room temperature in the glass, the ice melts. Water can change form between the liquid and the solid and the gas. You don't see it, but there's water vapor in the atmosphere too. And we also talked about that last week, how water vapor, when water evaporates, it makes water vapor in the air, and that's important for the climate too. So the fact that on Earth, it's the right temperature range, so water can be liquid, it can be solid ice, and it can be a gas. It can be vapor, and that's amazing. That's so important for Earth. If you think about what Earth looks like, if you were trying to describe Earth to a Martian or somebody who had never seen Earth, you'd say, well, there's rivers and there's oceans and there's mountains, and then you think about the shapes of all those things, and it's water. It's water that is evaporating from the ocean and forming clouds, and then it rains down from those clouds as a liquid, and it runs down in the rivers and carves rivers and grinds up rocks into sand. Remember we talked about how we get sand? It's that erosion of water running over things, and then the water runs back into the ocean, and then some of it's going to evaporate again. So you have this wonderful cycle of water in the ocean, and then in the ocean as a liquid, then evaporating as a gas, a vapor, and then it condenses into clouds, which are liquid again, and then it falls as rain droplets, and then it runs as a liquid over the land and carving rivers and grinding down mountains back into the ocean. And then some of it also freezes, and you get snow and ice, and all of this is water shaping our world and defining the nature of our world and creating the conditions that allows life to exist. So on this Earth Day, I just want to give thanks for this beautiful planet we have, and I propose a toast. Okay, let's cheers to water, giver of life and shaper of our planet Earth. I want to answer a question or two now that have come in. Here's one from Rylan or Rilan. I'm so bad at pronouncing names. R-I-L-A-N. Rilan. 10 years old. What makes the lava in a volcano, and what makes it erupt? Great question. Thank you for that question. Man, 10 years old. You kids are so smart. This is why I am optimistic about the future of our planet Earth, because even though we got some problems here, some of which we made our own problems, but we've got some really, really smart kids who are coming up and going to help us fix things on this planet. So what makes the lava in a volcano and what makes it erupt? Well, it relates to what we were just talking about, just the same way that water can exist in different forms. It's liquid mostly at the surface of the Earth because of the temperature at the surface of the Earth, but if it gets a little bit colder, it'll freeze. If it gets a little bit hotter than liquid water, it'll boil and you'll get vapor. So we call those different phases. It's all water. It's the same molecules, H2O. Remember we talked about H2O? Hey, notice my high-tech graphics got even higher tech. So you got a water molecule that's a hydrogen with two oxygens connected. Oh no, I did that backwards. Erase that part of the tape. See, even Dr. Funky Spoon makes basic mistakes. It's H2O, two hydrogens and an oxygen. There's the oxygen. And what's cool about water is that there's this sort of an angle. And there's the two hydrogens. It's not a straight line. Water's at this funny angle. And that turns out to be important in determining a lot of the interesting properties of water and the planet Earth. But if you've got water vapor in the air, or liquid water in the glass, or ice cubes, it's all the same molecules. It's all water. It's just that the molecules are interacting with each other in different ways. When it's a solid, then the molecules are locked in place and they're maybe vibrating a little bit. You know, they're like jostling next to each other. Like here's one water molecule, here's another one, and they're sort of jostling next to each other, but they're not moving anywhere. That's a solid. They're vibrating. And by the way, the faster they're vibrating it means the hotter that material is. If you cool it down, then those vibrations are chilling out and the molecules will barely be moving. But if you start to heat it up, then the molecules are like vibrating really a lot and pulling around. They've got a lot more energy when you heat it up. And if you heat it up beyond a certain point, then those molecules are not going to sit there next to each other anymore, just vibrating. They're going to start moving all around and they pull loose from one another. And when that happens, when there's enough energy so they pull loose from one another and they start sliding and moving all around and they're not stuck together, that's the phase transition. That's when it's no longer a solid, it's becoming a liquid. That's the difference. The molecules are the same, but when you heat it up enough and it melts and goes from solid to a liquid, the molecules are pulling apart and they're sliding around and they're moving and they're not all just sticking together. You know, it's like if you're at a concert and the music is playing and all the people are there moving to the music and they're just all kind of like moving, sitting down in their seats next to each other or just standing next to each other and they're bouncing around. That's like a solid. But then if the people start getting so excited by the music that they start running around the room and they're not always standing next to the same person anymore, that's like a liquid. The molecules get so much energy, they're floating all over the place. So that's what happens when matter melts from solid to liquid. And then if it gets even hotter than that, you can have a phase transition again, where the molecules, all of a sudden, they're not even just confined to that surface, that container that they're in, but they start flying off all around the room and bouncing off the ceiling and bouncing around the walls. And when that happens, then it's boiled off, it's vaporized, it's become a gas. Okay, so those are the three phases. The solid is when the molecules are all just like vibrating, sitting right next to each other. They can't really move. Give it enough energy, and it melts, goes from a solid to a liquid. And what's happening to the molecules? They're zipping all around the room, or they're zipping all around whatever container they're in. They're not stuck to their neighbor like a solid, like the molecules in a solid. And then heat it up some more and you get a phase transition. and the molecules start zipping all around the room, bouncing off the walls and the ceiling and filling the entire space that they can fill. That's a gas. Okay, so I'm going to get back to your question now, Rian, about what makes the lava in a volcano and what makes it erupt. But the reason I went into that business about the phase transition in water is it's the same thing with rock, or really with any material, that at a certain temperature it's going to be a solid because the molecules are locked together in a crystal. Like in a rock, the molecules are just sitting there, they're vibrating. They can't move anywhere. They're vibrating with respect to one another, but they can't really move. You heat up that rock enough and it becomes a liquid, and the molecules are sliding all around and moving freely. And that is the difference between rock, solid rock, and liquid magma or lava. When the rock melts, because it's hot enough, then it's the same molecules that made that crystal of the rock that was sitting there, but it's hot enough so that it becomes liquid. Now, at room temperature on Earth, at the surface of the Earth, ordinarily water is liquid, but rocks are solid. You know that on the surface of the Earth. But inside the Earth, it's hotter than at the surface. As you go down in the Earth, it gets hotter and hotter because there are sources of heat in the Earth from what we call radioactive decay. I'll get into that later. But anyways, just remember it's a little hotter generally inside the Earth than at the surface. And it's not the same everywhere because the inside of the Earth is, it's complicated. There are hotter places and colder places, and there are places where there's heat from inside the Earth welling up in big currents, and other places where there's colder rock that's settling down. But any place on the Earth, if you go deep enough, it's going to get hot enough so that the rocks will melt and you'll get magma instead of solid rock. And when there's a volcano, it's a place where that heat flow there's more heat coming from the interior of the Earth, and that's bringing up with it hot rock from the inside of the Earth. And as that hot rock gets near the surface, it can start to melt because you're in that zone of temperature where the rock is no longer solid, it's liquid. So you have liquid rocks basically beneath the Earth in places. And when it's under the Earth, we call it magma. But when it erupts onto the surface in volcanoes, because there's pressure under the Earth. And in some places that pressure pushes on that magma, that liquid rock, and forces it up into volcanoes. And that's when it flows onto the surface. And then we call it lava. Magma and lava, they're the same thing. They're both liquid rock, but when it's underground, we call it magma. And when it's flowing on the surface, we call it lava. And that's what makes the beautiful and strange and mysterious and sometimes scary structures we call volcanoes, and that activity we call volcanic eruptions or volcanic flows. And there's different kinds of volcanoes. Some volcanoes are violent and explosive, and you've seen the pictures where they're these big bombs of rock shooting out of the surface and falling down. That's usually because, well, there's a different kind of magma, and sometimes there's water in that magma that when it turns into steam, it explodes and it helps the volcano explode out, or there's gas inside that magma that when it gets near the surface, it bubbles out and explodes. And then there's other kinds of volcanoes that are not explosive, where it's more runny, and the magma and the lava is kind of bubbling and blurbing out of the surface and running along. So they're depending on what the rocks are made out of, and if there's water or gas, you can have a lot of different kinds of volcanoes. And sometimes they're more dramatic and explosive, and sometimes they're slow and it's just flowing along. It all depends on the details of what the rocks are made out of and what the area is like. But it's all the same. It's just molten rock that's hot enough under the surface so that it becomes liquid. Now, this leads me to another topic, actually, that I wanted to talk about, because I was talking about things I love about the Earth, since it's Earth Day. And another thing that's amazing about the Earth, especially, again, compared to other planets, now that we know about other planets, another thing that's amazing about the Earth is that it's so active, that there are volcanoes always going off somewhere. And there are earthquakes always happening somewhere, or often happening, frequently happening. And earthquakes are when their pressures are building up inside the Earth, and the two parts of the Earth are kind of pulling against each other, because the outer part of the Earth is what we call the crust, the solid part of the Earth. Sometimes we say lithosphere, which has a slightly different meaning, but it's basically the outer solid part of the Earth. And there are forces underneath the Earth because of those flows of heat that we were talking about. And sometimes you'll have two parts of the Earth that are sort of stuck together, but there's forces pulling, and then the forces get strong enough and they'll slide, they'll lurch. It comes loose and it shakes and moves a little bit. And that's when you get an earthquake. And those events, earthquakes, volcanoes, they can be scary. And they're dramatic, and sometimes they call it, they're natural disasters, and it's bad because people get hurt and things get damaged. But the flip side of it is that they're part of the activity of the Earth. And it's because the Earth is such an active planet that Earth is such a good home for life. If Earth was just a dead world, we've seen some other dead worlds. If you look at a picture of the moon, it's mostly a pretty dead world. It's craters, the surface is ancient, it's been sitting there mostly the same for billions of years. And there's a lot of the other planets and moons we see in the solar system are kind of dead. They're just full of craters. Not much has happened to a lot of these other worlds. They're sort of dead in terms of their activity. But Earth, by contrast, is so vibrant and active, and the surface is changing and in motion all the time. It's because we've got all that heat coming up from inside, causing volcanoes, causing earthquakes, and those can be scary, but it's that same activity that makes Earth good for life, because when that magma comes up from the interior, when that molten rock comes up from the interior, it brings with it minerals, it brings with it iron and magnesium and potassium and all these things that help plants to grow and help life to exist. And it also helps to keep the climate of Earth over the long run stays the same, partly because of that activity, because as the Earth brings rocks to the surface, it also brings rocks underground, and it pulls some of the what we call carbonate rocks down. It helps to regulate the amount of carbon dioxide in the atmosphere over the long run. It's that activity of the Earth that helps to pull carbon out of the air and also puts carbon back in the air through volcanoes. But there's a big cycle of the Earth, of the carbon and the nitrogen and all these other elements we've been talking about, and the oxygen. They're all connected to that activity of the Earth. So it's that great activity that causes these scary natural disasters like earthquakes and volcanoes, but also gives the Earth its ability to support life by constantly renewing the surface, renewing the chemicals on the surface, helping to regulate and maintain the climate. So it's a flip side. It's because we live on such an active planet that can be scary sometimes that we also are on a living planet. And by the way, the same thing is true about the atmosphere. The atmosphere of Earth is very, very, Lauren has a good, I'm gonna get to your question in a second, Lauren. The atmosphere of Earth is very unusual compared to most other planets, because the sun is heating the atmosphere and moving it around. This is why we have weather. We can learn together. We can understand the weather. The reason we have weather is because sunlight comes from space and heats up part of the atmosphere more than other parts of the atmosphere, because some parts of the Earth are at night and not being heated by the sun, and some parts are in the daytime, and that moves around. And also there's more sunlight at the equator than at the poles. So that difference in how much the atmosphere has been being heated causes the air to move around. And that's what allows all the wonderful rainfall and the changing of the planet that allows life to exist. But that weather can also be scary because sometimes it causes tornadoes, sometimes it causes hurricanes. So this is that same theme. It's the activity of Earth, the atmosphere moving around, and the solid Earth moving around. It's the activity that enables life through renewing the surface, through rain falling from the sky that helps crops to grow, that helps us to live, but also sometimes can lead to the scary natural disasters we have: earthquakes, volcanoes, tornadoes, hurricanes. It's all part of the same cycles. If we didn't have those scary parts of Earth, we wouldn't be on an active planet with life, and we wouldn't even be here talking about it. So all in all, I'm very, very glad that we live on such an active planet. Yay, Earth. Happy Earth Day. Now, a question just came in. Lauren, 7 years old from Maine. Hi, Lauren. Hi, Bonnie. Lauren wonders, why can't we hear in space? What was that, Lauren? Oh, wait, no, I can hear. I'm on Earth. I'm not in space. Well, this has to do with the nature of sound waves. We've talked a lot about light waves, and we've talked a little bit about sound waves. But the reason you can turn that around, Lauren, and you can say, you're asking, why can't we hear in space? Sometimes in science, it's fun to turn a question around and you can say, well, why can we hear on Earth? What is hearing? What is sound? And it turns out what we've learned is that sound is waves moving through air. So as I'm talking now, there's air coming out of my lungs, and it's being vibrated by my vocal cords, and it's forming sounds, which are then causing these these waves to move through the air between me and the microphone here, and that microphone on my laptop, and that microphone is turning those sound waves back into electronic waves, which are going through my computer and through the Wi-Fi and the internet and the satellite, and coming back out of your computer or your phone or whatever you're listening on, and it's moving that little magnet in the speaker. And that speaker, because the magnet is moving and causing a little cone in your speaker to move, that's turning it back into sound waves. And it's moving the air in the room that you're in, and maybe those little waves coming out of that speaker and moving through the air, and then waves are going into your ears. And then and then inside your ears, there's these little hairs that are actually being vibrated. It's weird, I know, but there's a chamber inside your ears with these little hairs, and those hairs are connected to nerve cells, which then go into your brain, and your brain is able to interpret that as sound. But the sound itself is actually waves going through the air. And so the reason why we can't hear in space is because there's no air in space, Lauren. It's a vacuum, which means it's not like a vacuum like we're going to clean up the floor of our house. It means that if you remove the air, like here I am in Washington, D.C., and if I walk outside, there's a certain amount of air, right? It's what we call surface pressure. And have you ever gone way up a mountain or up in an airplane and you feel your ears popping? That's because as you go up from the surface of the Earth, there's less and less air. There's less pressure, and there's actually less air. Like if I take, a certain volume, like imagine there's a cube here, 1 foot square on each side, and there's a certain amount of air inside this cube. And then if I go up to the top of a mountain and I feel my ears popping and I have that same cube, there's actually less air in that cube. The number of molecules of air is smaller. And if you go way high in an airplane, it's even less. And if you go way high in a rocket, it's even less. And if you go way up, 100 miles up from Earth, 200 miles up, you get to a place where there's basically no air, because it's the gravity of Earth that's holding that air down to the surface. And so you get high enough in space and you go out in space and there's no air. And then you can't hear in space because there's no air. what you can do, fortunately, Lauren, and this I highly recommend. If you go in space, Lauren, I think you should wear a spacesuit and a helmet with you should have like a walkie-talkie or a transmitter, a communication system so you can talk to the people in the spaceship or the people down on Earth somewhere else. And then you could hear. You wouldn't be able, if you were way over there in space and I was way over here and I was like, "Hey, Lauren, can you throw me that pliers?" You would just see me going, but you wouldn't hear a thing because there's no air between you and me. But if I had a helmet on and Lauren had a helmet on and I'm talking to my helmet little microphone, I go, "Hey, Lauren, could you throw me that pliers? I need to undo this bolt." And then Lauren's in his helmet and he, over his speakers from the radio waves, he's going to hear me and he's going to go, "Oh, sure." And he's going to toss that pliers and I'm going to grab it and use it. And I'm going to be, "Thanks, Lauren. That was a great throw." So, anyways, that's basically, groundwater too. You're so right, Peter. Yeah, groundwater is really important. There's so much. The thing about all these science stories is you can just keep going. You know, there's so many parts to all these stories. They are all connected. That's what I love about science, is that every story leads to other stories. And when I answer one of your questions, I'm always going, "Well, we mentioned these molecules or we mentioned that light last time," because it's all one big story. They're all connected. Science is knowledge and knowledge is power. And when I say that, I don't mean power like, "Oh, I'm going to be really powerful and push other people around or make lots of money." I mean, sure, science might help you do that. But what I really mean when I say science is knowledge and knowledge is power, I mean, it's very powerful to be able to understand things on different levels. And when you look out at a sunset, you can just sit there and go, "Oh, that's so beautiful. Look at those colors. I love this planet." And that's really cool. But that's fine in and of itself. But you can also, because you know science, you can go, "Wow, I'm seeing the scattering of light off of the atmosphere because there's molecules and there's light of different wavelengths. And, I'm hearing those bird songs and that's waves moving through the air and it's all making these patterns inside my brain." And, it's just like, wow, this is amazing. So it's just the power to understand things in different ways. How can be if there's other, oh yeah. Is there gravity on Earth-like planets? Yes. Is there gravity on Earth-like planets? Absolutely. Every planet has gravity. In fact, everything in the universe has gravity. If this mug was floating out in space, it has gravity that's pulling other things towards it. Not very much, because the smaller something is, the less mass it has, the less gravity it has to pull other things. And the bigger anything is, the more mass it has, the more gravity it has to pull in other things. That's why you remember when we talked about how planets grow, how planets are born from accretion. It's when you have all these pieces of planets forming, you have little planets, we call them planetesimals, the little planets. Yeah, when the planetesimals are pulling on each other by gravity, and then they stick and they make bigger planetesimals, well, those ones have more gravity, more gravitational pull on other objects. So as things grow, they become more powerful at pulling in other things, and then finally you get the big planets that are left. But yes, so every planet has gravity, and the bigger planets have more gravity. That's why we talked about how Venus is Earth's twin. I talked about that before, and it's because Venus is the same size as Earth, almost exactly. Venus is a little bit smaller than Earth. So if I had Venus and Earth both right here, you could see the difference. It would be like if Venus was a basketball, a regulation NBA basketball, then Venus would be a soccer ball. Just slightly smaller, but really very similar. And so Venus has just slightly less gravity than Earth, but almost exactly the same, which is why there was a question, I think 2 weeks ago, which was, what's it like on Venus? And the first thing I said was, you would feel, if you walked around on Venus, you'd feel the same gravity as Earth because it's the same size planet, has the same amount of mass, and so therefore the surface gravity, the force with which it pulls you down is going to be the same. Now, if you're on a much smaller planet like Mars, you'd have much less gravity. Mars has about 1/3 the gravity of Earth, so you could jump higher and it would take, you'd fall slower and everything. So, but yes, Earth-like planets have gravity, and the more Earth-like they are, at least in terms of the size they are, it also depends on what the planet's made out of. If it's the same size, but it's made out of pure metal, something with more density, some heavier material, it's going to have more gravity. If it was the same size planet, but it was made out of a giant cotton ball, it would have less gravity. I don't know of any planets made out of pure cotton, but maybe there's one out there that we haven't discovered yet. So good question. Yeah, all planets have gravity. Ones have more. All right, I'm gonna do another song here because I think it's time. And this is a song that I just learned, like literally about half an hour ago. So, oh, whoops, where did it go? Darn it. Hold on, I have to pull it up here. Oh, there it is. Okay. And I'm still kind of learning it. So it might not be fully polished, but, you know, this is science. You know, we throw things out there and then we try to improve them. That's what science is all about. And on the Funky Science Story Hour, we're not afraid to make mistakes. But this is a song I like. If you know it, you can sing along. And I thought it was appropriate for Earth Day because this is a song by somebody named Tom Rush, and it's called Mother Earth. And it goes something like this. Oh, first of all, it's got this like kind of drum feel to it. So you can drum along if you want. Something like that. Mother Earth lives on the ocean. Mother Earth sails on the sea. I am blessed with her devotion. Mother Earth provides for me. Now I am going on a journey, and I pray all things end well, while Mother Earth looks after me. I will follow faithfully. Green trees grow on mountain tops. Birds still sing while morning comes. Though I treat her carelessly, Mother Earth provides for me. When the grasslands crave for water and the harvest needs sunlight, these are times when I am helpless. Mother Earth makes all things right. Oh, Mother Earth is on the ocean. Mother Earth sails on the sea. I am blessed with her devotion. Mother Earth provides for me. Mother Earth provides for me. Mother Earth provides for me. Right. So a song for Earth Day. All hail Mother Earth. All right. I agree. All hail Mother Earth. Okay, I had a couple questions that I still didn't get to from last time. Let's see. Well, this is a fun one. Life on other planets is often depicted with arms, legs, eyes, mouth, ears, and intelligence. So, did the aliens experience the same successful evolution of the Homo sapiens? What would the odds be? That's a cool question. And it's something that astrobiologists think about a lot. If we find life elsewhere, should we expect it to be the same as life that we know about here on Earth? Well, that's in some ways, if you look at the evolution of life on Earth, you see that in some ways it's random, which meaning it takes turns, that it's just kind of going this way and that way. And that if you had a planet exactly like Earth and you evolved life again, it wouldn't end up looking and being exactly like the life that's here now. Because if you look at what's led to us being here alive on Earth today, there's a lot of sort of accidental things that happened. 65 million years ago, there was an asteroid or a comet that smashed into the Earth. But the difference in the angle of your eyes for different distances is information that your brain uses to figure out how far away things are. And you do a similar thing with your ears, which helps you figure out where sounds are. Yeah, hello, people coming back. It ended mysteriously, so I just started it again. But so there's value in some of these things. We have 2 eyes, 2 ears. And would aliens have hands with 10 fingers just like ours? 5 on each hand? Probably not, but they probably have something like fingers and thumbs, right? Because it's very valuable for us to be able to manipulate the world, to pick things up, to play guitar, to throw things, to everything we do to manipulate the world. So I bet you, I don't expect there to be aliens with 5 fingers on each hand, but would they have something like arms and hands? Sure. So because these are good what we call adaptations. Adaptations are things that evolve to help us live in the world. So I think that aliens would have some things in common with us. And intelligence is a really interesting question. Would aliens have intelligence? Do we have intelligence? What is intelligence? Duh, I don't know. No, I guess you could say intelligence is the ability to take in information, sense things about the world, and figure things out that will help you behave in a certain way so you could survive. And if you look at intelligence that way, then of course it's going to evolve elsewhere where there's life, because if life evolves senses, then with the information from those senses, it's going to need the ability to make sense of the world, and it will be valuable to have something like a brain so that you can figure stuff out and make decisions and behave in a way that helps you to survive. So some of these qualities that humans have, I think we could find on life on other planets, but it won't be put together the same way. And also, no planet's going to be exactly like Earth. So the different environments, who knows what will be different? Maybe the air will be different. We talked about the gravity being different. There'll be different needs that an organism has. And so it will have evolved both differently, both because of the randomness of evolution, the weirdness, that just strange twists and turns that evolution takes, and then also it will evolve differently because on different planets the environment will be different. So I think that when we get to meet aliens, I don't know when that'll be, but I'm sure hoping it's not too long, because I would love to be alive for it, that there'll be things about them that we recognize. There'll be aspects of their bodies and the way that they function in the world that will make sense to us, that we'll recognize. We'll say, oh, those are eyes, or oh, those are, arms, or whatever. It'll have things that are similar to things that we see on Earth organisms, as well as some things that we've probably never seen before that are adaptations unique to that planet. But they won't be exactly like Earth creatures, because there's something very particular about a path of evolution that probably would not repeat itself. So great question. Thank you. Thank you to those of you who rejoined me after the broadcast mysteriously ended and restarted. And I'm going to go out now with the Funky Science theme song, because I see that we're basically at an hour. And I know a funky hour is often longer than a 60-minute hour, but not always. The thing about a funky hour is that you never know exactly how long it's going to be. And we're coming to the end of this particular funky hour. So we're going to go out with the Funky Science Story Hour theme song. And I just want to say a very happy Earth Day to all you people. And thank you so much for joining me. And let's keep it funky, keep it real, and remember to always ask why. Gather round, my children, pull up a chair, my friends. Let's all get together for the story that never ends. How do we get here? What's inside your head? What's bluer than blue? What's redder than red? Gather round, my people, all children, young and old. Pull up a seat, put up your feet for the greatest story ever told. Funky Science Story Hour, 'cause science is knowledge and knowledge is power. 'Cause the world is so weird, and weirdness is fun, and there's so much to learn, and we've all just begun. Oh, we can learn together, we can understand the weather. We can imagine ourselves in any place. We can see the Earth from outer space. How do we do that? Oh, with science. Funky, funky science. Oh, science, science. Funky, funky science. Oh, funky, funky, funky science, yeah. Oh, with science. Funky, funky science. Yeah, science, science, science. Funky, funky science. Oh, funky, funky science. Funky science, yeah. Oh, we can learn together. We can understand the weather. We can imagine ourselves in any place. We can see the Earth from outer space. Yeah, Funky Science Story Hour, 'cause science is knowledge and knowledge is power. 'Cause the world is so weird, and weirdness is fun, and there's so much to learn, and we've all just begun. Oh, science. Funky, 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 funky science. Oh, funky, science. Yeah, funky science, yeah. Funky science, yeah. All right, peace out, everybody. I'll see you next time. Happy Earth Day. Peace and love.